Um, Good evening, everybody, and welcome. Let me quickly present. Let me start by presenting my screen. So, just tab. All right, everybody can see my screen, right? So, welcome back to Explore ML Study Jam session number two. Like I was saying, welcome to Explore ML Study Jam session two. So, in our last session, we were able to look at some machine learning concepts, and we even had fun playing a game. So we looked at those concepts using videos, right? So one thing is, so maybe from the last session, some things weren't clear. So we're here to sort of go over them once again, but in a very fun way, right? So before I start, I'm going to try and make this session very quick. And before I start, I saw this. So some time ago, I found this very nice tweet that I related to like 100%, in fact, 1000%. So it basically goes like this. So she says, Intro to machine learning books makes so much sense after you have at least 5 years of experience in machine learning. Now, this is like basically trying to tell you that sometimes these ML concepts can be too much too fast, right? So, just give yourself time. If not everything is clicking, give yourself time. With some time, it's going to click. Now, obviously, this 5 years that she mentioned is just it's an exaggeration, but it's just trying to tell you, okay, give yourself some time to understand these things, right? All right. With that said, um, so today's class is going to take a little bit of a different approach. So last time it was video centric. This time it's going to be story centric. So I like stories. If you've not figured out that by now. So
Sorry to cut you. I think your screen. I don't know if you are sharing your screen, but you are just seeing the first bit.
yes, the screen is there. So um, I'm going to start with this. You're going to picture a scenario, right? You are in your house as a data scientist. You're in your house. You live in a very high-tech house, okay? And then all of a sudden you start to smell gas somewhere, like cooking gas, you know, and the place started to get like warm. The temperature is becoming, hotter and hotter. So your instinct begins to tell you that, oh, probably something is burning somewhere in the house. So your house being the tech house it is, it has a lot of sensors, right? So you go on, you look at this hub where it shows you basically your temperature, your smoke. It reads smoke. It's able to read humidity. It's able to read LPG, which is like cooking gas, right? And so when you looked at this sensor hub, you saw that the values were spiking. We have high values of temperature, smoke, humidity was low, so that means like the air was dry around the place. Basically, things that show you that tell you that there's a fire occurring somewhere in your house, right? So you rush upstairs and you find out that okay, somewhere is actually burning. You discover fire, so you call for help basically to put out the fire, right? So now this incident, right? It got you wondering, like you're a programmer now. This thing should be automated. Your house was catching fire all this while, and you were not able to like detect that very quickly, right? So you decided, oh, I'm going to write code for this. I'm going to automate this thing. So you got on your keyboard fiercely because you're not smiling again. Thing has really riled you up, right? And you came up with code that looks like this. Okay. So when you were checking your sensor hub, you saw that the temperature, when the temperature got higher than 45, uh, you know, okay, so let's say the values were getting higher, higher, higher than 45, like they were growing from 45, right? So, and that was telling, it was like a sign that there's fire. And when the humidity is low, so that's when air has very little moisture. And when there was high readings of smoke, and there were high readings of LPG, and that's like cooking gas, and then there's high levels of CO. And so when all these things come together, that tells you that, oh, probably there's a fire going on somewhere in your house, right? And so this is basically the logic that you designed, and it's all about input versus output, right? So here the inputs that goes into this your logic are these things: the temperature, the humidity, the smoke, the LPG, and the carbon monoxide, right? And the output is whether there's a fire or not. So this is your own logic for predicting if there's fire or not. Now you've built your system that detects fire occurrences, right? So you're happy now. Now, all of this is you before coming to explore ML study jam, right? That was before you got exposed to machine learning, right? So you came to explore ML, and then you now know about machine learning models, and you know that, oh, during that time I just went on saying stuff about models that can learn from, that can learn to understand patterns from data, so that I don't have to write this logic myself, right? I don't have to go through the stress of writing logic myself. And he kept on mentioning things like data, 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 machine learning models learn from data, blah, blah, blah. So that just kept on going on and on about data, right? So what does this data that I've been talking about even look like, right? Like, I've been shouting data since. What does it look like? So I'm going to show you like a real world snippet of the kind of data we work with in machine learning, right? So drum roll, boom. Now this is an example of the kind of data that we work with, right? So what is going on here? There's a lot of things happening in this slide. You're seeing every column is like an input, like a feature, right? Every column contains an input feature, and then the last column is the output, right? So here basically 0 means off and 1 means like on. So that's like when there's fire or not, right? And every single row here is an example. Now, what is an example? An example is just one instance, right? It's just one sort of let's say a measurement or something. Like, it's just the readings at a particular time, right? So let me show you how. Okay, how would you go around gathering this data? Okay, so let's say after your fire incident, your tragic fire incident, you decide you remember that, okay, one of your friends at some point, his house caught fire at some point in time. You remember, let's say early last year, yeah, your friend's house caught fire. So you call this your friend and you say, hey, Alpha, I remember that your house caught fire around last year, that period. And I know that you live in a high-tech house too. All your friends live in high-tech houses. Could you give me the readings of LPG, smokes, and temperature and humidity that you discovered when your house was burning, right? So when they send you those readings, they've given you an example of the readings when there was fire. I don't know if this clicks, right? They've given you an example of the readings that you get when there is a fire, right? And then you can actually just tell him that, oh, okay, look, give me examples of your house, like give me readings of your house right now when I'm sure there's no fire. So you now have two examples from that your friend. So let's say he gives you this and this, right? This is an example for when there's fire, that's from last year, and then this is the example from right now when everything is normal in his house. So that's basically how this data is generated. It's just what examples, right? Like, is someone trying to say something? Okay. All right. Um, what was I saying? So this is the data. This is how you gather the data, right? And this is just let's say you're the kind of person that labels his friend. So this is friend number 59, friend number 9, friend number 35. I don't know why someone would number their friends, but yeah, that's who you are. So again, I'm going to show you a real world snippet of a machine learning model. We've been talking about it since, so let me show you what it looks like, right? So another drum roll and boom. Now there's a lot going on in this slide, right? So let's dive right into it. So the first line we see here is basically creating our classifier basically, and I'm going to talk about this in more detail in the coming slides, right? But for now, let's focus on these things from here. So basically here we are setting our inputs, we are storing our inputs, right? We're storing the columns of our inputs, so LPG, CO, smoke, temperature, and humidity. These are our inputs, right? These are the things that allow us to predict whether there's a fire or not, right? And it makes sense to use these things as inputs to a system that tells you whether there's a fire or not. So basically, we're just gathering them here, and then here we're saying, okay, this is our output. And in this line, we're saying, okay, classifier.fit. Okay. And so we are saying from this data set, from this data set, pick where you see LPG smoke. So basically just pick the inputs, right? And pick the outputs. So classifier.fit expects two things. The first thing it expects is what you want me to use and what you want me to predict. So input, output, features and output, right? And classified of fit basically just means it's just, in fact, as the name says, fit. It's just like telling it, go to the gym, use these inputs as your weights, right? So when it's done fitting, it's now a gym bro. You say, okay, classifier dot predict. So now that you know the relationship between these things, you know how much LPG sort of affects fire, like you know how much the LPG reading matters to determine if there's fire or not. Now that you know that for every single feature, right? With these readings, please predict, tell me whether there's a fire in my house or not, right? So this is how this is how a machine learning model, like the code looks like, right? So we've been talking about machine learning model since this is basically how the code looks. It's very simple, easy to grasp, right? So um
Okay. So while we are waiting for him, I'll just start working on it. It'd be great. Okay. So while we are waiting for him, I'll just like I don't know if someone can just brief us. Like I don't know if someone here is actually has started delving into or has tried their hands in basically like in practical or real world machine learning. I don't know if there's anyone that's done something like that. Like you've done some real world projects or something like that. Is there anyone on this call that can just share your experience with us so that at least please don't whine. Yeah, I feel like you are even a machine learning expert. Abdullah, I think you are. You've done some one or two now. Share with us your experience while we wait for the instructor to be back. Abdullah, can you hear me?
Yes, I can.
Okay.
It's about to learn. Yeah. Okay. You were saying,
Yeah, I was saying if like some real world projects, probably like I don't know if you've got your hands dirty on some machine learning project, you can just share with us something just to encourage. Let us just encourage ourselves. Just know that okay, yeah, this is actually something real, not something that you just get to play around or something.
okay. So I think over the years, I have I've actually worked on a couple of machine learning projects, especially in groups. So there's this particular one. There's this particular what 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 do you call it? Organization called Omdena. I think they are interested in pushing open source machine learning. So they basically gather people who are interested and also skillful in machine learning to work on real life um real life problems to solve real life problems using machine learning, especially in Africa. So I was opportune to join one of their cohorts like that. So we worked on ways to how do I put this? So we basically worked on something related to finances, how we can use machine learning um to push adoption of financial technologies among Nigerians. So
Wow.
the experience was nice. We get to interact with people. The first thing I think we did was to gather information on why people might have trust issues with fintech applications and the rest. So we hit the street like that, and we get to interact with a lot of people and get their inputs. Then we come back. We had a brainstorming session. We brainstorm on the input we got from the people, and then we start working on gathering data. So I think gathering data was a bit tricky because of the financial most of the financial data are what do you call this? Um,
Bias?
are with the financial institutions like banks. So and they are not accessible for free. So I think
Oh,
at some
okay.
point we have to pay the one of those fintech companies to release some fraction of data so we can use to train the machine learning model. So that's how we went about it. We were able to develop the machine learning model and put it into production. And then, yeah, so basically that's how it went. But the experience was really nice because we, I feel like we're actually solving something that will help a lot of people. So it was satisfying for me.
Wow, that's wholesome. That's awesome. That's an awesome experience. Like sometimes I used to wonder because I know that this data gathering is one particular issue, especially in Nigeria. Especially when you're trying to, for instance, there was one time, I think there was one time I was trying to look for data sets on agriculture, like agricultural data set, and man, it was really quite an headache. Like it was okay. Our instructor is back. So maybe we just continue later so that we don't waste much of our time. But I think it's also one issue we might need to stay address in this class. So over to you, Dario.
So somebody might say, okay, why do we even need a model to go around and learn these relationships, right? Because it was somehow straightforward, right? We had a logic that worked well. So if the temperature value is high, if the humidity is low, so we could actually write logic. Why do we need something that will go and learn the relationship between these things and how they affect whether there's a fire or not, right? And so my response to that question is basically two scenarios. Scenario number one is where you have much, much, much more columns to deal with. Right. So before you were dealing with only five columns. So just temperature, CO, smoke, humidity. So what if you are dealing with much more columns of data, right? You have to start writing, okay, if the age is so value, if the gender is so value, if the gender is 2, if the degree I think of difference is 3, if the bone is 1, if the bone marrow is 2 or 1, you begin to start writing these complex logic. It gets really complex really quickly, right? And you can see by yourself. So um, that's one scenario where it's just best to use machine learning. In fact, it's not feasible for you to start writing these long conditionals, or it becomes too complex. And in fact, when you write that long if statement, that would just be covering one instance. Like it's just too complex, too quick. Another scenario where a machine learning model is just best is when your data looks something like this. What does this even mean? How do you interpret ATT1 or ATT2? In the other one, we had temperature. So it's an everyday thing, right? Everybody knows what temperature is. So you were able to interpret what your features were, right? But this time you just have something like ATT1. What the hell is ATT1? Attribute 1. How do you interpret it? What is ATT5, right? So it's just best to have something that is automatic, like it just learns the relationships automatically, right? So that's I hope with this now I've convinced you that for some cases it's just way better to use machine learning models. And in fact, sometimes it's just infeasible to use um, you know regular logic. So coming on to so basically, the key takeaway is that almost everything that has inputs that describe it, in this case, fire, right? It has inputs, temperature, humidity, LPG. These things kind of hint you that there's fire, right? These are features of like that can tell you whether there's a fire or not. So it's always input versus output, input versus output, input versus output. So other examples we could look at, right? Say you want to buy a car, a used car, right? So, and your budget is around 1 to 5 million CFA, right? So the things you would look at if you want to buy a car is the brand. You could look at the brand. Is this a Tesla? Is this Toyota? Obviously, the Tesla is going to kind of be more expensive than the Toyota, right? And then the model. Obviously, even in Toyotas, there are like high tier Toyotas, mid tier, and low tier Toyotas, right? So that is going to affect the price that you let's say this is the price that you want to bid, right? That you want to like tell the seller, "Oh, this is you want to predict, right, based on these features, right? And then obviously the year a car produced in 2010 not going to be on the same price level as something in 2022 now. So yeah, and then of course the mileage too. A car that has traveled just 100 kilometers will not sell for the same price as a car that has gone for thousands of kilometers. Okay, so given these inputs, you can sort of infer the price, like a reasonable price for that car, right? Okay. And we kind of do this thing every day. It's an everyday thing for people. Another example is housing price. So you want to get a house, you look at the features, you look at the size of the house, you look at the number of bedrooms, you look at the neighborhood of the house, and look at how old the house is, when was it built. These are things that can affect the price of a given house, right? Another good example is say something like student performance. You want to predict what their GPA would be from 0 to 5. I don't know if you guys use 5 points grade system, but we use that here in Nigeria. So I don't know how it is in Cameroon. So you could look at things like class attendance, how punctual is this student, right? So that kind of positively hints at a higher grade. Past performance, you could look at the students' past results. You could look at assignments completion. You can look at the number of hours spent at the library. All these kind of indicates that the student's going to perform, probably going to perform high, right? So you have these features that tell you that you can use to predict, okay, the performance of the student. So maybe given a particular a set of examples, you could learn from that and then predict, okay, so with these new values, will the student get something like 2.5 or 3.8, like that. And then another example, and really the thing I want you to pick from these examples is that you can apply it to almost anything. Another example is choosing whether predicting whether you're going to go to class that day or not, right? So the features you can look at is the place, is the day sunny? Is it, some people, don't like stress. It's too sunny outside. I'm not going to forget the class, right? And if it's if it's raining heavily, in fact, even the lecturer might not show up, right? Another feature you could look at is the lecturer probably going to give impromptu tests? So the thing with some of our lecturers here is that some of them like to give impromptu tests, especially when the attendance rate is very low. Right? So you can look at things like that kind of prompt you to go to class. So it pushes you towards the yes category, right? These things push you towards the yes category. And then lastly is something like, how interesting is the class to you? At times it's not even about the topic that's going to be treated in class. It's more whether you find it interesting or not. It's going to push you more to go towards the class. Okay, so these are features that can that you can use to predict whether you're going to go to class that day or not, right? So if you carefully look at the things that we've been doing, if you carefully look at what we have been predicting, they are of two types. There are two patterns of predictions that we have. Now, the first is where we are predicting kind of a range of values, right? So what I mean here by range is when what we are predicting kind of has in between values, right? So something like car price. Now, when you're predicting the car price, you could predict a value of, say, anything between 1 to 5 million. You could predict something like 2.5 million. You could predict something like 1 million and one. You can predict something like 1,248,000, right? You get my point. They are in between values. You could even predict something like 1,024,083, right? So when you're predicting a range of values, when you have a range of values to predict from, right? That's different. That's called that's a regression task basically. And then talking about classification is where we have A or B. Basically, there are no in betweens. It's either yes or no, right? It's basically categories. You have different categories that your prediction comes in form of. So I don't know about you, but I've never heard of something like yes point 0.5 or no point 0.5 or yes point 0.7, right? So there are no in betweens. It's either yes or no, right? So another example of that could be when you're trying to predict a person's race. So you look at them, you want to know whether they are Asian or black or white. So there's nothing like I am black point 0.5. No, no, no. You're either Asian, black, or white. So the two types of predictions we have basically is one where we're predicting like from a range, and the other where we're predicting just a category. Right. So the range is where we have in between values, and the category is where we don't have any in between values, right? An example of that is something like here where we're predicting a number between 5 million and 30 million. That is a range, right? But when we're predicting just A or B, yes or no, that is like basically category based. So uh, that's a classification task, which then explains here where we have classifier, right? There's fire or not. There's nothing like there's half fire. It's not possible. So we're predicting a category. It's either there's fire or there's no fire. So that's why we're using a classifier here. I hope that makes some sense. Okay. So now quiz time very quickly. If you are going to predict the number of visits to a hospital, right, that's our output goal. Very quickly, just type in the message box. Okay, Abdullah, says maybe it's yes point 0.5. That's interesting. Okay, what about yes point 0.7? What would you call that? But very quickly, if I want to predict the number of visitors that come to a hospital, um, what kind of task is that? Is that a regression task, or is that more of a classification task? Very quickly, just type in the box what you think it is. Let's do a quick exercise. regression. That's one. Let's have solutions from more people. Regression, okay. Regression, okay. Yeah, that's great. Yes, the answer is regression, right? So what about something like whether you should choose to borrow this person your money or not, right? Not how much you're going to borrow them, but whether to borrow this person your money or not. Yes or no? Like very quickly. Awesome, awesome. So yes, classification. And then so given a this one is a little bit different. Given a picture, you're to determine or to predict whether this the person in this picture is President Muhammadu Buhari or President Paul Biya or is it President Joe Biden? Is this classification or regression? Okay. So yeah, yes, classification is the answer. So that brings me towards the end of our session. So quickly, I'd like to say that okay. So fun fact: all of the pictures you see here, all of the pictures that you see here, this one with the woman here, the high tech stuff, all of these pictures, I generated them using stable diffusion. So it's an it's an AI. So there's a generative AI model that allows you to basically type use generate images with text prompts. So you write out what you think, and then it's going to generate a picture of that for you. So in this case, so the first one I used lady inside high tech house, and this is like just one of the things that make AI so beautiful. So just with very quickly just typed lady in a high tech house, boom, I have this image. Smart home hub, something like that, that displays temperature readings. I have this fire caught in a room, something like that, and I have this picture very quickly. Now, this very picture has a funny story. So when I typed, okay, lady, I think it was. Let me check the prompt. So, lady going at her keyboard programming. So when I typed it basically showed me pictures of a lady programming, but that lady that it was showing me, basically all of them, they were smiling. And it doesn't look like, you don't smile when your house just got burnt and you're trying to program a solution for that. So what I did was that, so that there's another text box that allows you to put negative prompt. So what that negative prompt is just anything you don't want in your picture, you put it there. So I put smiling. So remove any element of smiling in the picture, and this is what I got: a very fierce looking lady going on programming her fire detector solution. Yeah. So um I'll put the link up in the chat, so just so if you want to play with stable diffusion, right? um, you can play with it. And okay, so I have a couple of things also, assignments. So the first assignment is for you to basically frame, just come up with something that we can use machine learning to do. So come up with, excuse me, come up with features and outputs. So come up with something that we can predict using machine learning, and then write out what the features would be. So basically just like what we were doing um, over here, right? So write out what you're going to predict and write out the features, right? You can just be creative, come up with anything that you want and put it on the WhatsApp group that we are all on, right? And then that's assignment number one. You can come up with two of these things, two. And then assignment number two is to have fun with stable diffusion and send in your pictures and prompts that you get from stable diffusion. um yeah. Finally, if there's any questions, I'll be taking questions now. Thank you very much. Yeah, go ahead. I see a hand raised.
Okay, good evening, sir. Although I missed um a session of the class about 20 minutes before now, but then I joined in when you were talking about the types of prediction, that's the classification and regression. So my question now is, when we are talking about the stable diffusion that you can make a prompt and then get images from them, is it that the it just allows us to view the image or the images could be downloaded? That's just the clarification I need. Thank you.
Okay, thank you for the question. Yeah, when you go there and you basically type your prompt, what you want, it will give you the option. Like you can, if you're using your computer, you can right click, save the image, and that's basically even what I did. I just save those images so they can be downloaded.
Okay, thank you, sir.
Thank you very much, Ma. Does anybody have another question? Okay. So, um, it looks like we don't have any other questions. So the session for tomorrow is going to be a Python overview. Like we're just going to go over Python so that when you go to basically do the Kaggle courses that we're going to send to you, it's going to be easy for you. You have some background about machine learning, you have some background about Python, so you can just go ahead and you know mother the course basically. So if that is all. And since we don't have any questions, Daniel, is there anything you want to say, you want to add before we go?
Nothing actually. I'm just thinking of different ways to use machine learning. Um, for instance, like call rejection,
Yes, we need that, man. We do. We really need
or
that.
using machine learning to filter maybe like my prospective maybe prospective wife or prospective client.
I
Okay.
expect that to be in your assignment submission. Thank you very much.
So I think someone is asking a question.
Okay, write out the assignments. So we'll quickly do that.
Okay, I think we can do that on the group. So on the WhatsApp
Yeah,
group,
yeah,
you can just put that
yeah,
there. So if
yeah.
you are not on the WhatsApp group, kindly indicate. Okay, let me just drop the link so that if you are not on the WhatsApp group, you can just join. And because that's what we'll be having more of like more of the discussion. We can't be having meetings every day, but we can always be discussing on the group so that when there are challenges and you're facing you need to start. Okay, yeah, when there are challenges and all, so you can always reach out. So I just dropped the link. Yeah. All right. So nothing from me. Over to you, Dairo.
Yeah, I think. Okay, so someone said, okay, so I'm going to write out the assignments on the group, and then the slides I'm going to send them on the group as well. So
All right. Is there still anything, Dairo? Because I see you're not
no,
saying
no,
anything.
no.
All right then.
I was saying I'm going to send these to the group, and I'm going to see you guys tomorrow.
All right. So thank you very much for the session. Really, really appreciate. I've learned quite a lot, and I'm sure everyone on here has also learned one or two things. So if there's nothing else, then we can just call it a night. But please, let's give a round of applause for our instructor. He has really killed it tonight. Yeah, I can see you, July.
Thank
All
you guys so
right,
much
all
for
right.
handling. Yeah.
All right, thank you very much. Thank you very much. All right, guys. Good night. Good night. Bye.